Hi, welcome to the next lecture in the NPTEL series on Haskell programming. In this lecture, we will look at a particular library which is very useful, which is, and this is also is a common feature in other programming languages, namely arrays. We will show how to use arrays in Haskell. To be clear, these are what are called immutable arrays. Okay, what we mean is that once you create an array, it is very efficient. So what are the properties? Let's just lay down some properties. Can create an array of length n. It is easy, which means that it is efficient. Constant time to access any element of the array. Once a value is stored in the array, costly to change it. Okay, costly means order n time. Okay, but we will see that there are lots of problems for which all you require is constant time access to the elements. You do not necessarily require to modify the value once it has been defined. And Haskell also has what are called lazy arrays, which offers you a lot of flexibility in how you define the elements of the array in the first place. Okay, so all these are properties. Let us now look at some of the details of arrays in Haskell. List store a collection of elements. Accessing the ith element takes I steps. It would be useful to be able to access any element in constant time. And arrays is the data structure that offers this feature. And you have to import the module data.array to use arrays. So let us just go to VS Code and check that the current installation I have actually already supports arrays. So I have this program where everything is done using arrays. If I try to load, okay, good. So you can get arrays to work with this. And I can try the same thing that I tried earlier, which is that what is A? A is something like this. B is another large string, and I can say LCS ASB that will return some value. It's of length 42, and that is the actual longest common subsequence. And all this is programmed using arrays. Okay, and you can see that it is quite quick. Okay, let's see the details of arrays now. Unlike lists, arrays have to be finite. This is important. Okay, in fact, you should specify the size upfront. There is no dynamically growing arrays, right? Okay, So here is what we do. You have to import data.array, and you can actually declare an array int char. What is this int? This int is the index, type of the index, array indices. Type of the value stored in the array. And what is list array? Create an array from a list. Oh, how do I know which element to put where in the array? In that order. So the list is listed as A, B, C. So you put A in the first position of the array, B in the second position, and C in the third position. But like with lists, arrays also are indexed from 0. So it will be indices 0, 1, 2, which will contain the values A, B, C. Okay. So now the indices of the array come from int. The values stored in the array come from char. 0 is the smallest index and 2 is the largest index. So your array itself looks like this. Index is 0, 1, 2 and value is A, B, C. Okay, and list array is a function that's of type I comma I, which gives you the lower bound of the index, minimum index, maximum index. Okay, that is two values, and I should belong to the type class okay, should belong to the type class ix, which means index. Okay, and you have a list of elements of type E. E is the type of the values of the array. And finally, your output is of type array IE. Okay, so that is what list array is outputting. So that is the function. E is the type of value stored in the array. Ix is the class of all index types. So types like int and char are all index types, and these are types that can be used as indices in arrays. That's all that we need to know now. You can even have some pair types, etc. as indices, because I can just all I require is that I can mention some lower bound and upper bound, and there are only finitely many elements in between the lower bound and upper bound. That's all I want about indices. So if if A is an index type and x and y are values that belong to the type A and x is less than y, then we choose finitely many many indices between x and y. Okay, there are only finitely, okay, what you mean is that there are only finitely many indices between x and y, many values between x and y. So the class ix includes int, char, things like int comma bool, int comma char, etc., where you can do some kind of appropriate ordering of pairs such that between any one pair and another pair there are only finitely many pairs. Okay, so you would appropriately order it, and the index class provides such a thing. It does not include things like double or list int, because if it's comparing two lists, you cannot you have to compare lists according to lexicographic ordering, and you cannot say that, oh, between any two lists there are only finitely many other lists. There could be infinitely many. Okay. Okay, so here are examples of list array. List array of 1, 100 to 199. Actually, I should show this to you on VS Code, which I will do in a second. List array of 1, 1. This means that the lower bound of the index is 1, upper bound of the index is 1. So only one element is stored. At index 1, what is the value stored? 100. So you will keep on storing elements in the list as long as your array has not been exhausted. The moment it has been exhausted, you discard the rest of the list. Okay, so only 100 is used. List array of, as you can see here, you can also use characters as indices. MP, between M and P there are 4 values, M, N, O, P. So 0 to dot dot dot, that's an infinite list. It is the array where the lowest index is m, the character m, highest index is the character p, and at character m, at index m you store 0, at index n you store 2, at index o you store 4, and at index p you store 6, and that's it. The array stops. The array has to be finite, even though the list is infinite. List array of b comma a 0 dot dot is the empty array because b is not below a, b is actually above a. Okay, so there are no elements between b and a. There is no element such that there is no element x such that the character b is less than x and the character less than or equal to x and the character x is less than or equal to a. Okay, and that is why you have this as the result. List array of 1 comma 3. Now this tells you that the lowest index is 1 and the highest index is 3. And if I give the list A, B, then you will get an error because 1 will be associated with A, 2 will be associated with B. There is no element associated to 3. So you will say, oh, undefined array element. Okay. So let's try all these things in VS Code. List array of 1 comma 1. Right, I have just one this thing. List array of what was the next example I gave? Right, so this is another array. If I say P M, I want all elements that are greater than or equal to P and less than or equal to M. There are no such, and even if I give an infinite list here, I should get the empty list as a result. And finally, list array of 1 comma 3 of 0 comma 2 here will provide an exception, right? It says that there is an undefined array element. Okay, good. So when you use list array, you should make sure that the list which you are converting to an array should have as many elements as there are positions, indices in the array. Okay, let's get back to the slides. So this is important. To access an array element, you will use array single bang. Okay, double bang I to access okay, great. And this works in constant time. This is very, very, very important. For list, this takes I plus 1 steps or whatever. I steps, let us say. Okay, for list it takes time proportional to I, as I said. Okay, so array at I throws an exception if no value is defined at index I. Suppose I say my array is list array 1 3 ABC, and if I ask for my array 4, I will get a problem. It say, oh, my your index 4 is not even in the range. Okay. The most important thing about Haskell arrays are that these arrays are they are lazy, which means that we can access the element at index I as soon as it is filled, even when there are other unfilled slots. I can keep filling. So unlike in other languages where I need to declare an array and then initialize them with some value or whatever, here there is no such thing. I can actually keep filling the array while using, so this is the important thing. I can use already filled values in the array to fill to new values. Okay, this is the important thing. So for instance, here is a here is a program for Fibonacci numbers using arrays. I'll say fib of n is fib array at n, at the index n, where fib array is nothing but list array 0 n, right? And this is the important point. This is the minimum index, that is the maximum index. The value I am going to fill at index I is defined by f of I. F can use already filled values. Right? This is most important. So f is defined as follows: f of 0 is 0, f of 1 is 1, f of I is, rather than saying f of I minus 1, f of I plus f of I minus 2, I am saying fib array of I minus 1 plus fib array at I minus 1, right? Fib array at I minus 2 plus fib array at I minus 1, because the way in which I am doing this, so what happens is that it is not even that I need to follow some particular order. What happens is that when Haskell tries to fill in the array element at index I, it will make a call to f of I that will refer to fib array at I minus 2 and fib array at I minus 1. At this point, now you can make a call to f of I minus 1. Right? So what do you want? I only want array elements to have a definition that can be later expanded. Not necessarily filled with a value. Okay, so this is what you mean by lazy. This is what is laziness. Okay, great. This is a program, and you can actually see how quickly this program runs. Let me now go to VS Code and show you this. Okay, here I have a program for fib, which is exactly what I wrote in that thing there. So let's just actually try to do fib of 10,000 I said, and you get immediately a value, because you don't even need any particular cleverness here. There is just one pattern, which is that I define an array, and for every element of the array, the ith element of the array is defined to be some f of I. F of I uses the array elements in some j, k, etc. You can do whatever you want. Okay, and this is a very straightforward pattern. There is no cleverness, nothing required. Let me get back to the slides. So fib of n runs in time order n, because initially it will try, you are calling fib of n, it will try to access the nth element of the array. But the nth element is not filled in, but there is a definition which is f of n. So f of n refers to fib array of n minus 2, fib array of n minus 1. So it will try to access fib array of n minus 1, n minus 2. It is not yet filled in, but there is a definition, so it will try to expand that definition. So it will go on, but the point is, the second time it tries to access fib array of n minus 2, it will already be defined, so it won't expand it to f of I or whatever, it will just pick up the value. Yeah. but the second time you just pick up the stored value. Okay, so this is it. Okay, good. So that is why it is running in time order n, and you could see how fast it was. Okay, so list array is one way of creating arrays. Here is another way of creating arrays called array. Okay, here instead of giving a list, you give an associative list. Okay, you say explicitly at this index I want this value, at this index I want this value. Okay, so that's another way of doing it. Yeah, so this is building from an associative list. So the associative list need not be in ascending order of indices. So you can say array of 0, 2, then you can say 1, 1, 2, 2, 0, 0. Yeah, this thing, it will finally store it in ascending order, but you don't need to present it in ascending order. Elements can also be omitted. So you can say array 0, 3, at 0 I want ABC, at 2 I want XYZ, but later array 0 and array 2 can be accessed, but array 1 cannot be accessed right now, but you can later go and fill in the array at 1 before accessing it. Okay, and there are some functions that belong that are defined for any type that belongs to class index, range. Okay, which if you give a lower bound and upper bound, it should give a list saying all elements that lie in between this. Index, which is that if I give you lower bound and upper bound and give you a particular index, it will tell you what is its position in this. In range is again, if I give you lower and upper bounds and I ask for another index whether it lies inside these bounds, it should tell whether true or false. And a range size will tell you the length of this list. Okay, great. So for instance, range of 1 comma 3 is 1 2 3. Range of m comma p is m and op. Range of z comma a is nothing because there is nothing between z and a. Index lu ind returns the position of ind in the list l dot dot u. Index, if I have the thing minus 50 and 60 and if I ask for the index of minus 50, it is 0. If I have minus 50 and 60 and I ask for the index of 35, it is 85 because minus 50 to 0 and then 1 to 35. Index of O in MOP, in MP, the range is M and OP, O lies as the third element, but indices start from 0, so 0, 1, 2. Index of A in MP is, there is no A in MP, so you will get an exception. In range, again, the same kind of thing as I told you, you can see these examples. Minus 50 is in the range minus 50 comma 60, 35 is in the range minus 50 comma 60, A is not in the range M comma P. Finally, range size gives you the size of the range. Okay, this as I explained already. Okay, this is just about arrays in general and what more you can do with indices, etc. Here are some other functions on arrays. So this is access in constant time. That is the important thing. Okay, bounds of an array will give you the lower and upper bound of the indices. Indices will give you the list of all indices. Elims will give you all the elements, and assocs will give you all the associations. A list of pairs which tells you at this index this element resides. Finally, you have this, which is an update. I have an array, I say update this array by putting these values at these indices, and it will do that, and it will take order n time. Actually, order n time, even if the list is of length 1. Okay, great. So these are all some functions on arrays. Yeah, array slash this assoc list will update entries in array based on the I comma e pairs in assoc list, and that will take order n time, as I mentioned. Now actually we can use arrays to solve this LCS etc. problem that we had earlier. It is now really simple. You take the naive LCS solution, you just convert it to arrays as follows. The code is more straightforward than the list based version, does not require any cleverness at all, okay, and uses array laziness very crucially, and you can even avoid the bang bang on strings, as we will see in a minute. Yeah, so this is it, this is the whole program. What I am doing is LCS of A's B's is nothing but I am creating an LCS array, okay, whose indices are pairs of integers. So I will finally pick the element at index 0 0. Yeah, this also makes that whole matrix clear. I am creating a matrix and I am picking the leftmost topmost entry of the matrix. But what is the size of the matrix? The size of the matrix, it goes from row 0 to row m, column 0 to column n. M is the length of A's, n is the length of B's. And even A's and B's, rather than keeping them as lists, I will keep them as arrays. A array is the list array 0 comma m A's, that is it, okay. B array, list array 0 comma n B's, okay. Yeah, in fact, I might even just have said m minus 1, n minus 1 here, okay. The way I have stated in these slides, there is one extra index with no element attached to it, but that is okay. LCS array, which is the main thing that we want to define, is nothing but this function called LCS memo, which I am just calling it. Instead of calling it f, I am calling it LCS memo, because I am memoizing. As soon as I compute, I am storing it in the array of I comma j, where I comes from 0 to m, j comes from 0 to n, okay. And what is LCS memo of ij? If I is equal to m or j is equal to n, this is the bottommost row and topmost column. I just need to store 0 comma empty string. 0 is the length of the longest common subsequence, empty string is the longest common subsequence. If A array at I want to in general compute some element here. This is I and that is j. If this is A array here, that is B array. If the ith letter in A array and the jth letter in B array are the same, then that has to be included, right. So 1 plus L, A array at I, yeah, A array at I is that letter colon S, okay. What is S? We will come to that, L comma S. L is the length and S is the sequence. If L1 is greater than or equal to L2, then I choose L1 comma S1, otherwise I choose L2 comma S2. What are L, S, L1, etc., nothing. L comma S is LCS array, the value of LCS array at this, at the diagonal. L1 S1 is the value of LCS array here to the right, and L2 S2 is the value of LCS array at the bottom. One row straight, and this is extremely straightforward. The program does not involve any cleverness or anything at all. Once you have the naive solution, you can just translate it into this array. Note that this is lazy, so I can refer to LCS array bang I plus 1 j plus 1. If the element is not yet defined, that does not matter. If there is no element, if there is no field number there, that does not matter, because that has been given a definition, it will be lazily expanded, okay. All you require is that every element has a definition, namely LCS memo, okay. That is it, okay. It is as simple as this. The program is very straightforward, and you get all the efficiency that you need. And LAS is very similar. LAS is longest of LAS array bang I goes from 0 to n, where n is length of A's. A array is list array of 0 comma n A's. I am storing A also as an array, and A is also as an array. This LAS array is list array 0 n LAS memo, okay. That is my function of I. What is LAS memo of I? If I is equal to 1, then I know that the longest ascending subsequence is empty sequence, so this is correct. Otherwise, I will I'll extend some sequence with A array at I. What is the sequence that I will extend? I will go look at LA's array bank J for all J from I plus 1 to N. Look at those where A array of I is less than the first element there. That is why I am checking this. And yeah, that's what I am checking. And I am picking the longest among those, and I am just appending my A array of I before that. That is it. Okay. So the point is here referring to an array element which will spawn a call to LAS memo the first time it is accessed. And use the stored value for subsequent calls. Okay, so that's it about arrays and how you can use it to efficiently program these dynamic programming tasks, etc. So now I shall just demonstrate these programs on VS Code, and that would be the end of the lecture. Let us go here, and I will see that I have, yeah, so I have LAS array. This is exactly the thing that I have shown in the slides. And LCS is also just the same. It is the same template. It's a very simple template, and you can use it to solve many kinds of dynamic programming problems. Okay, so let me just check. LCS I have already shown. Fib I have shown. Okay, I have a huge string A's, I have a huge string B's. I can try LCS A's B's. What happened? Yes, I still get a, yeah, these are really huge strings, so it will take a little bit of time, but it's fine. I'm getting a result. With the naive LCS, you won't get anywhere at all. And let me also do XS is rand ends. Rand int list. Yeah, you see, very quickly you get a result. Okay, so I hope you can appreciate the efficiency that arrays give you. It's quite easy to use, and yeah, and it gives you all the efficiency that's possible. And this particular approach to dynamic programming is very nice. And arrays in Haskell being lazy is an extreme convenience. Okay, thank you. That concludes this lecture. We'll see in the next lecture. Thank you.